Hydroboration oxidation reaction. The reaction looks like this. You start out with an alkene. You're going to have CH3 groups. This will be our hydrogen. The first step is the hydroboration attached to THF, so that it is known as explosive. The second step is the oxidation step. H2O2 and NaOH, aqueous. And that will give an anti-Markovnikov alcohol. So the first step is the actual hydroboration step. You start out with your alkene, hydrogen over here. You're going to assume your THF is here. And you have your BH3, so say BH2 and then H here. So this attacks and is attacked at the same time. And that gives you a transition state. The transition state looks like this. You have your H2, your H here, and these are your equals to CH3s. And that gives you your anti-Markovnikov intermediate. The next step is the oxidation, and this one is not that complicated, it's just a little bit tedious. So you start out with your H2O2. Let me just write it out here. So you start out, let's see, H2O2 plus OH negative. Your OH negative takes one of your H's, and you are left with HO negative and water. So you're going to use your HOO negative and the thing you just created, your intermediate that you created in the last step with your BH2 group here. I'll just draw it this way, make it simple. So the the O2H negative is going to attack your BH2. And you're going to end up with this. You're going to have the BH2, but you're also going to have this attached. And you've got your lone pairs there. And then what's going to happen is you're going to have a hydride shift. This attacks here. This goes over here. And then you are left with your bromine here, hydrogen here, OH, and then your OH negative group. Okay, so then you take this, doesn't want to focus, there we go. Bromine, hydrogen, OH, add another OOH negative. That's just going to attach onto here. And that gives you bromine, you have an OH on one side, OH here, hydrogen up there. And then you have the same thing that just happened up here. Hydrate shift down here, this disappears. Leaves you with your bromine with an OH over here and OH over here. Plus your OH negative that you just lost right here. All right. Take this intermediate and you're going to do kind of the same thing again. Leave your bromine, OH on this side, OH on this side. You're going to add in an OH this time, an OH negative. Sorry, you're going to add an OH negative. Just going to attack over here, and it will give you this kind of horrible looking thing. And this time you have this bond shift here, and you lose this. And that gives you this intermediate. So you still have your two OH groups, and this is just shifted. The bond has shifted from here to here, and you've lost that. And then you've got your OH negative that you lost there. All right, so then you're going to take this intermediate, and I'll draw it out one more time here. So you've got oxygen, BHOH2. You're going to add in your OH negative. That's just going to tack right here. That gives you OBOH3. And then this is just gonna, this is actually negatively charged now. It's gonna leave. It's a good leaving group. It's negatively charged, wants to go. And it's gonna leave its electrons behind. All right. And then you're gonna end up with an oxygen attached here that has an extra electron, negatively charged, and your bromine with its three alcohol groups attached. And then you're just going to use water on here that you have, excess water. So you'll just take this with the negative charge. It'll take some water that you've got here. It'll take one of the H's. All right. And then you will end up with an anti-Markovnikov product right here, which is what you got up here, which is a whole lot of steps to get that. So first step is the boration. Second step, all that, is the oxidation. And that is to get the anti-Markovnikov product. So anti-Markovnikov means that the group that you're adding on, in this case, the alcohol, ends up on the less substituted side of the alkene. If you were going to use demercurization, oxymercurization, you would get the Markovnikov and the OH would add on over here. But hydroboration, oxidation gives anti-Markovnikov, so your alcohol groups ends up on this side, where there's only one methyl group.